probably the most famous and most well-used method for solving systems of equations is called substitution. You might have even used it already without knowing it, because it makes sense to you. For example, you may have used it in grade 9. If I tell you, this is the first equation. This is a grade 9 substitution question, but they didn't tell you it was a substitution question. And this is the second equation. Can you tell me what x is? Can you tell me what y is? I will tell you the x's. Any guesses what x could be? X plus y plus 4, this is a 4, equals 0. And then the second equation is x plus equals 2. And my first question is, can anybody tell me what x is equal to? It's 2. It's that easy, right? I mean, in grade 9, they don't then ask you what x is, because you can tell. But can you tell me what y is? Negative 6. Because that's what would make it equal to 0. And technically, there are two equations there with two variables, an x and a y. However, the x was super easy. And what you did to find y is, in your mind, you substituted in a 2 where the x was. That's what you did. You used substitution. You changed one thing to something it was equal to. That's basically what substitution is, but in our substitution questions, we won't have a number to substitute in. We'll have more algebra. So what we're going to do, and the steps for this, is we're first going to get, maybe we have a similar equation. You have 2x plus y equals 6. And in the second equation, they tell you that x is equal to y. So now I didn't tell you the number. And you don't know what x is, and you don't know what y is. However, what could I substitute in the first equation? I'm going to rewrite the first equation, but instead of writing x, what could I write instead? Y, because they're equal. So I did a substitution, and I substituted the y for the x because I was told they were equal. And now can you tell me what y is? 2. Y is 2. And now can you tell me what x is? 2. Right? Because they're equal. But in order to see that, we did a little substitution. And once you get an equation with only one thing that you don't know, you have your grade 9 skills to solve for it. So this is what the substitution technique is. It says, first, can you get a variable all by itself? Like, and I gave it to you. X was all by itself. It was equal to y. Right? I could make this question more difficult if I told you that x was equal to y plus 1. Because then when you substituted in, you would have to replace that with y plus 1. And now we have a fraction as an answer for y. I think it's equal to 4/3. But we could still solve for it. Once your variable is isolated in one equation, we do exactly that. Where that variable is in the other equation, you substitute in. So if I got x by itself was equal to y plus 1, I could then, where the x was in the first equation, replace it or substitute it with a y plus 1. And then I end up with that equation in the blue box that just has y's, and you use all of your skills from grade 9 to solve for y and get y by itself. So after step 2, we substituted. You now have an equation with only one variable, and you can solve that equation. Then Once you find that first equation, like I just said, did the mental math here, I figured out that y was equal to 4/3. I can now find x because I know that x is y plus 1. And if I plug in or substitute the 4/3 in for the y, and I add 1, I would get 7/3. So then my x value would be 7/3. So I just picked a random example, got fractions as answers. Sometimes you'll get nice values for answers. Sometimes you could get fractions as answers. And what we found was that between these two lines, the point where they cross is 7/3, 4/3. If we tried to solve that one graphically, it wouldn't work out nicely, because it's not a nice point where they cross. So this is why this method overall is more popular than the graphing method. For one, the graphing method, you have to take a big chunk of your paper to draw graphs, kind of annoying. Plus, it really only works well if you have actual graph paper or an actual graph, because if you just try to do it by hand, you might be off a little bit. So the graphing method is like, you need a lot of things in order for it to work well, and then sometimes, even with all of those things, it doesn't work well because the points don't cross at a nice place. So then this substitution method works better. So let's look at an example with the substitution method. The first thing you're going to do with the substitution method is you're going to look at both of your equations. I'm going to number them. This is equation number 1. This is equation number 2. I'm going to look at equation number 1 and equation number 2 and try to decide if there is a variable that's easy to get all by itself. Sometimes there isn't, and you just have to, but sometimes there's one that's easier than other ones. This is such an example. There is a variable that's easier to get by itself, the x or the y. The y. And would you use equation 1 or would you use equation 2 to get the y all by itself? Equation 1. Can you see that in equation 1? There's a y all by itself. Like it just has a coefficient of 1. It's not all by itself on one side of the equation, but there's not a number in front of it. It would be fairly easy to just subtract 4x on both sides to rewrite equation 1 like that. Maybe I'll color code things. I'm going to write equation 2. Anytime I'm working with equation 2, I'm going to be in green. Anytime I work with equation 1, I'm going to be in blue. Because it's important that you always have to then, we're ready to substitute, but you have to substitute into the other equation. And sometimes you're going to substitute back into the original equation. If you substitute back into the original equation, you will find out amazing mathematical facts, such as 5 equals 5. 3 happens to equal 3. 7 equals 7. And you will have you'll be like, I'm trying to solve for x, and I get 7 is equal to 7, but I still have no idea what x is. When you substitute, you have to substitute into the other equation. Substituting one equation back into itself will just have everything cancel out, and you will get one number equal to another number that you already know. Do you want to see it happen? Right? If I substitute, don't write this down, but if I go, oh, this means I can now rewrite the y with negative 4x plus 1. So if I rewrite the y with negative 4x plus 1 equals negative 4x plus 1, I can add 4x to both sides and I get. But have I solved for x? No, but I know that 1 is equal to 1. But if we substitute into the other equation, I got the y by itself, so equation 2 was 2x minus 3, but instead of y, what will I write? because I'm rewriting the second one, but instead of writing the y, I put a big set of brackets. And what is the y equal to? Negative 4x plus 1. And now our equation 2, which we're working in green, just has x's. And if I do my math like, oh, I have a 3 out in front, I'm going to have to distribute. This will become plus 12x minus 3 equals 4. I have like terms. This will be 14x. I can add 3 to both sides. Gives me 7. I can divide both sides. By 14. And I get 7 over 14, which means that x is a half. How did we get the 7? I saw these were like terms, but they were on opposite sides, so I added 3 to both sides. Now, if you're finished writing it down, make sure that everything's made sense to you. Is everything good? Question.
Do you get the fraction at the end?
How did I get the fraction at the end? Well, if you want to get x by itself, what's the opposite of multiplying? I'd have to divide this side by 14, so I have to divide this side by 14. That would give me 7 over 14, which reduces to 1/2. So now we have figured out x. But to solve this completely, we need to find x and y, because we are looking for that point graphically where they cross. And we now know that the x coordinate is 1/2. How do you find the y coordinate? Again, you're going to use substitution, but now you're going to substitute the value in. And you can choose to substitute it in either into equation 1 or into equation 2. Okay, I am going to find y using my blue equation, because in my blue equation I had y by itself. It was -4, but instead of x, because I now know what x is, I can write a half plus 1. What's half of -4?
2.
-2. And -2 plus 1?
Why is it negative?
Because -2 plus 1 would be
No,
negative.
but why did you,
Oh, yeah, why?
why is it negative?
You move to the other side of the
This is a 4. Are we good? Okay, again, make sure you've written it down. Make sure you understand each of the steps and ask questions if you're unsure of anything. So we always write our solution as a point. The x coordinate is 1/2. The y coordinate is -1. Yes, Aaron. Yes, you could substitute into that. You could substitute into that. Yes. So Aaron's question, he said, you found y by substituting into this blue equation, right? He substituted it into this equation, It worked out the same. If you substitute it into this equation, it will also give you the same one. In fact, when you get your solution, right, 1/2 negative 1, does equation 1 work? If x is half and y is negative 1, does it equal 1? Yes. Does question 2 work? If x is a half and y is negative 1, does it equal 4? Yes. It has to work for both of them, right? That's our solution. Can you see that? I should have got you to try and guess and check in 3 seconds on this one, but I don't think you would have found it, because I don't think you would have tried half. And this is a good example of, okay, we can sometimes guess and check quickly to see what works, but only if the numbers are really easy mental math ones. And most of our equations are going to be a little bit more difficult with mental math, so we need a method. The first method that we looked at was graphing. But this point, can you see that on a graph? That wouldn't be perfectly on, like, little crosshairs of your graph. So you'd be like, kind of guessing. So this method of substitution is really nice, and it's probably the most famous method for solving. Ready for the next one? Yeah. Okay. I'm going to do equation 1 again. All my work with equation 1 in green. All my work with equation 2 in blue. And we have to make a decision if there's a letter that we want to get by itself, if there's a letter that we see would be easiest to get by itself. What are you thinking, P or Q? Q? I agree. Would you use equation 1 or equation 2? 1. Equation 1. I agree. Can you see that you could get Q by itself in equation 1 by, here's my equal sign, I'm going to put the Q on the right-hand side, I'm going to move the 14 to the left-hand side. And you're going to start to be able to do some of that as mental math, okay? What did you do in grade 9? In grade 9, you might have showed plus Q, right? That's perfectly fine, but you don't need to show that. If you can start manipulating algebra without showing that, that's fine, okay? Just, as with math always, we try not to make mistakes. But I got the Q by itself. Now, I have to substitute that into equation 2. So equation 2 was 3p plus 2q equals 8. But now, instead of the q, I put brackets. What am I going to write in there instead? 3p minus 4t. And we have created an equation that only has a p. So now we use all of our skills in algebra from grade 9. This 2 would get distributed, so that would be 6p minus 28 equals 8. We look, do we have like terms? Yes. 3p and 6p would be 9p. This 28 and 8 are like terms, but they're on opposite sides, so I would add 28 to move it to the other side, giving me 36. And p is equal to 4. And put a little circle around that because that's part of our solution. What do we still need to find? We need to find q. I'm going to use the green equation because in the green equation I got q by itself. Q was equal to 3p minus 14. And so q, 12 minus 14, is going to be negative 2. Oh, I forgot to get you to guess and check at the beginning again. you had to guess and check now, what might you try first? 4 and negative 2. So now we can write our solution. We always write our solution as a point. Ooh. But what do you write first? P or Q? I think I'd write A, B, C. P comes before Q. So I would probably write P comma Q, but just to, I'll write it like this. Whoops, that's not black. This question shows that it doesn't have to be X and Y, it can be any letters. You don't have to, when you're graphing, you could graph these, but you'd have to decide the vertical one is Q, horizontal one is P, and then you could solve this graphically. That would work as well. What the letters are doesn't change the algebra, okay? But we do happen to get used to graphing with X's and Y's. I don't know who made that first decision. We're going to use X's and Y's, right? It could have easily gone with P's and Q's. It could have been like, why do they have to be in a row? It could have been that we use M's and W's to be like, flip them around. I don't know, maybe that wouldn't be a bad idea. But it's arbitrary. But sometimes when we get used to things in a certain way, we can't work outside of them. Equation 1 in green, equation 2 in blue. Which letter looks like it would be the easiest to get by itself? B. And would you use equation 1 or equation 2? Equation 2. I like it. You are correct. It would be easy. Move the A over. Negative 2A plus 7. And then I would rewrite equation 1. I'm already going to distribute the 2, but where the B is, I'm going to put a big set of brackets. Does it make sense to you when you look at equation 1 that that is rewriting equation 1 except for where the B was? And in that hole where the B was, I'm going to write and substitute in negative 2A plus 7. And this time I'm going to remember, guess and check. All right? See if you can figure out what A and B is. Try some numbers. I tried 2 and 3 first. Did anybody try 2 and 3 first? Didn't work for me. I think I got it. Yeah, I think I got it. I guessed and checked it. Hmm? Two, it is right here, but I did this right away because I knew I would have to do that anyways. All right. It took me more than 3 seconds though. But I guessed and checked. I think I got it right. Now let's check. Now that we have our algebra here, what can we do? This is going to be 2A plus 2 distribute. I'm going to get plus 6A minus 21 equals 5. Do we have like terms? Yes, this will be 8A. This is minus 19, moved to the other side will be 24. Divide by 8. And I got a is equal to 3, which matches up with my guess and check. Next, I would have to find b. b is equal to negative 2 times a plus 7. A little bit of mental math there. Negative 6 plus 7 is 1. Circle that. My solution is 3, 1. Now, since I already guessed and checked that and figured that out, I've already know that that's right. But it's if you didn't figure it out beforehand, at this point, take 3 and 1 and try equation 1. Does it work? If a is 3, this inside the brackets would be 4. What's 2 times 4? 8. Minus 3 times 1? Minus 3, 5. Perfect. Equation 1 works. Plug in 3 for A and 1 for B in the second equation. It works. Okay? So the nice thing about these questions is you can always check if you're right. I like that about math sometimes. You do a question, you check, you got it right, you're like, feel good. I feel like I know that I can go on to the next question. I also like that about math because if I get an answer and I check it and it doesn't work, it's like you basically told yourself, would you like a second chance? Or you figured out that your answer doesn't work, would you like to just leave it wrong? Most students would go, yeah, I'll take the second chance. And you get to do that before you hand in your test. So if you check over your answers, you're able to find out whether you've got it right or you've got it wrong. And if you've got it wrong, it gives you a chance to do it again. If you keep getting it wrong, sometimes that happens. That probably means there is something that you are misunderstanding and you deserve to get it wrong. Because you're not understanding something completely. Yes, you deserve to get that wrong. And then when you get your quiz or your test back, you're like, I want to know what I did wrong here. Because obviously I'm misunderstanding something. Okay, one more, and it has fractions. What's that? You got this one by guessing and checking? Nice. I'm going to call this my equation 1. This my equation 2.
If that was like on a test or something, can you just do it by guess and check it? Put that down, or would you?
No, you still have to show the, if it's, because especially on the test, it'll probably say solve by substitution, then you have to show that. But then you know that your answer is right. Or it'll say solve by graphing. Okay, which letter looks, or which variable looks easiest to get by itself? X. Good, because the y has fractions. Okay? Does it really matter which equation, 1 or 2? They're probably equally easy to get by itself. So which one do you want to get the x by itself on? The second one? Okay. It really doesn't matter, but it's really easy to get x by itself. I would just have to add y over 4 to both sides. Now x is by itself. Now if I got x by itself in equation 2, I have to substitute it into equation 1. Otherwise, we'll find out a beautiful fact like 3 is equal to 3. So, I take that, and where the x was, I'm rewriting equation number 1, but instead of writing the x, I wrote this at the bottom of your page, right? Okay, because I'm going to erase it, so it's out of the way. Okay. And now we are dealing with fractions in an equation. There are a couple of options when dealing with fractions in an equation. You can keep the fractions and deal with them, or you can temporarily get rid of the fractions. Okay? This one, can you see that the -1, first of all, I'm going to rewrite it. The brackets are not necessary now. Because the brackets are just holding numbers. There's no math to do outside of it, no distribution. So I can take away the brackets. Can you see that you have a -1 and a -5 that are like terms? So I could add 1 to both sides and get -4. What do I want to do with the fractions? Can you see that the fractions have a common denominator? This is y over 4. -3/4 y. Can you see that that's the same as -3y over 4? Does that make sense to you, that -3/4 y is the same as -3/4 times y, which would be like y over 1, which is equal to -3y all over 4. We have to know our fraction rules really well because we're going to be manipulating things in algebra. So does it make sense that -3/4 y is the same as -3y over 4? And then, if that y was written that way, -3y over 4, can you see that this term and this term have a common denominator? And if you took 1y over 4 and you minus 3y's over 4, you would get minus 2y's over 4. Agreed? Is that good? Now, I want to get y by itself. What can I do? I could multiply both sides by 4. Perfect. That would give me minus 2y equals minus 16. And then, to get y by itself, divide by minus 2. And I get y is positive 8. Aaron, is that what you got when you guessed and checked? Uh-oh. So we might have made a mistake. We're going to find out. But once you've found y, we can now find x. I'm going to use the blue equation because I got x by itself. X is equal to y over 4 minus 1. Yeah. 8 over 4 is 2. 2 minus 1. So, we got our solution to be 1, 8. We can check mental math if it works. I'm going to scroll up to the beginning. I'll scroll back down afterwards if you need to. Okay? If x is 1 and y is 8, does equation 1 work? 8 divided by 4 would be 2. 2 times 3 is 6. Is 1 minus 6 negative 5? Yes. Second one. Y is 8. 8 divided by 4 is 2. X is 1. Is 1 minus 2 negative 1? Yes. So our solution works. Now, mathematically, the rules for solving equations are What you do to one side, you do to the other side. And because that is such a simple rule that always works, you have options. There's lots of, it's like a map. There's not only one right way to solving an equation. You have different options. Okay? In this equation, in the green, what did I do as option 1? I put my like terms together to get the -4, and then I had -2y over 4. Neil suggested multiplying both sides by 4. You're allowed to do that, because what you do to one side of the equation, you do to the other. Got -16, divide by -2, got 8. Did anybody, when they saw the 2 over 4, say to themselves, I can simplify that fraction? Right? Because what's 2 over 4? 1/2. So, if we did that, I would have -y over 2 equals -4. I could still multiply by 2, and then multiply by a negative. I would still get y equals 8. That's another option. Okay? I want to show you another option. Lots of people. Here we go. Lots of people like this option. They're like, ooh, I make lots of mistakes with fractions. And this has fractions. We're dividing things by 4. So what would happen if I got rid of that fraction? I took both sides of the equation and I multiplied everything by 4. Multiplying by 4 and dividing by 4 would cancel each other out. So if I multiplied this by 4, I would just get y. If I multiplied the -1 by 4, I'd get -4. If I multiplied this by 4, I would get rid of my fraction, just have -3y. And if I multiplied the -5 by 4, I'd get -20. I'm allowed to do that because what I do to one side of the equation, I do to the other side of the equation. I can now combine my like terms. Y minus 3y, that's -2y. Add 4 to both sides, and I would get -16. Divide both sides by -2, and I would get y equals 8. And I didn't have to deal with any of the fraction work because I got rid of it. Perfectly fine. So you have options. Anything that you're allowed to do with algebra, anything that you do to one side, you do to the other, you can do that in an equation. So sometimes you solve an equation, you might re-look at that same equation you just solved and say to yourself, could I do it in a different way? And sometimes one way will be you'll like better than the other, and sometimes the other way you'll like better. There's going to be places where there's shortcuts available, but those shortcuts are only available if you know all of your options all the time and think about it. All right, take out your textbooks.